Good evening. I am Somak from University of Hyderabad. I am a research scholar there at School of Mathematics and Statistics. Today, I will solve previous year assignment problems of week 8. First, I will tell you something about divergence and curl of a vector. Then, I will move to question answer solving. Okay, so first, uh, visible. Is the screen okay?
It's okay.
Okay. So first I will tell something about divergence and curl, then I will move to the questions. So first is suppose f is a vector. So first I will tell about gradient. That is let del. This is an operator called nabla or gradient operator. Suppose this is given by this del x1, del x2 up to del xn. Okay, somebody wants to join, so let me. Is the screen visible? So suppose del is an operator which denotes del operator. So gradient of a scalar is a vector. So f is a scalar. It is a vector where f is a scalar function. Okay. So so when divergence will come if I take capital F as a vector field where it is C1. That means this is gradient, this is different. Divergence means, so divergence, is let F is a vector. So F1, it has component F1, F2, F3, be a C1 function. C1 vector field, not a function. Vector field means it has both magnitude and direction. So F1, F2, Ft are its components. Be a C1 vector field on at some domain, on domain omega, which is a subset of R3. Then what is divergence of F? Divergence of F, that is written as this grad dot F, that is equal to, what is grad operator? I del x plus j del y plus k del z dot f1 f2 f3 means f1 I vector plus f2 j plus f3 k, right? So this is just I dot I is 1, so I'll write del f1 del x plus del f2 del y plus del f3 del z. This is so this term is called divergence of f, where f is f1, f2, f3, this vector. Okay. So, what is it means? So, divergence of a scalar is a vector. Divergence of a vector is a scalar because it is a number, right? Del f1 del x plus del f2 del y plus del f3 del z. This is a number. It has only magnitude. So, divergence of a vector is a scalar. So what it means physically? Anyone knows what do you mean by divergence physically? Okay, so I am talking about divergence of a vector field first. So suppose F is a C1 vector field. Divergence of F is given by this whatever I wrote in a this square box, red color. So divergence of a vector is a scalar. So can you tell me what is its physical interpretation? What do you mean by divergence of a vector? Physically, what it means? Anyone? Abhitotha Roy.
The divergence refers to the thing when, from a particular point, the vector field that diverges outwards.
Uh, Always okay. Always not always outward. Divergence is a scalar, right? So it has either positive or negative. It has some sign, right? So I'll write. So vector field means what? Divergence of a vector means it is a vector field, C1 function. So vector field can be represented as fluid flow, velocity of fluids. As so suppose divergence represents that how much this fluid tends to flow out of a small region. That means there is something called source and sink. Source and sink. Suppose this is source means fluid are going out of this region. Okay. So here divergence is positive. And sink means in this region it is coming. Sink. This is called sink. So here divergence is negative of it. Or in other words, suppose another example I will give you. Suppose there is a streamline flow. That means fluid is going through this channel. Suppose this is the streamline flows. And so what do you mean by the source and sink? So suppose I add some water in this channel. Suppose I remove this barrier. Sorry, I remove this barrier and add some channel. So flow will increase. This is suppose this is input and this is output, right? So if I add this channel, the output will be more. So divergence of this fluid is, suppose F represent the fluid flow or F represent the velocity of the fluid flow. So if I add some source, this is called source, then output will be more. So here divergence is positive. So in similarly, suppose you have one channel and you have one portion where your flow is going, but through another channel it is going downwards. That means input and output flow it will be very less. So in that case, divergence is negative. So what divergence actually means? It means that change in the total mass flow of rate of water, whatever water or whatever it is there in the channel, that will depend. So divergence represent change in mass flow means total flow. What change? The rate changes, rate of the water. So suppose divergence is zero means what? What do you mean by divergence zero in these two cases?
That means there is no flow through the additional channel which we have made.
Yeah, that means the flow is incompressible. Means there is no external source or sink, whatever. This is called sink. There is no external channel. So if divergence of zero means flow is incompressible, that means the fluid is incompressible. Incompressible fluid. Okay. So this is called divergence. So divergence is a scalar. So divergence is either positive or negative. So whatever you are saying outward Okay, just 1 minute. So divergence. Yeah. So the outward inward, it depends in which direction the flow is going on. That means how much this the fluid tends to flow out of a small region. In the small region, how much it tends to flow out of that region. So this is physical representation of divergence. Similarly, what about curl? Curl of F. What do you mean by curl? As you know, I hope that curl means this cross product with that del operator that I told first. What is del operator here? So cross product with the del, F is a C1 vector field. So F is an C1 vector field. So I am asking about what is the physical representation of curl? Can anyone tell me? Physical representation of curl. Anyone? First of all, curl is a vector. It's not a scalar. Divergence is a scalar. Curl of a vector is a scalar. Sorry, curl of a vector is a vector. Divergence of a vector is a scalar. So what do you mean by what is physical representation of curl? Any idea? Abhitata Roy, you are telling something for divergence. So any idea for curl? Okay, I will tell. So curl means how much the fluid rotate around a point. Fluid means vector field, okay? So if I say fluid, that means I am talking about capital F, vector field. That vector field, this thing. So fluid means a vector field. It has both magnitude and direction. So curl means how much, curl physical representation is how much fluid rotate around a point. So how you visualize this? I will tell. Fluid means vector field. Okay, so I will write for you. Fluid means vector field. Okay. So uh, di- so curl is a vector. So direction of maximum rotation about any point in a vector field is actually a curl. So what does it mean? Suppose you have a channel fluid. You have a river. River is in river. Water is flowing. So if you see here in the down below, velocity of the fluid is less. Velocity of the fluid is less, but in the up, velocity of the fluid is high, right? That is natural. Have you ever seen river flow? This is called streamline flow, streamline or river flow, whatever. So velocity in the upper it is high and velocity in lower it is less. Suppose you put one circular tube or something like that. So can you tell me in which direction it will rotate? It will start rotating in which it is clockwise or anti-clockwise?
If it's a streamlined flow, then there won't be any
Huh?
collisions.
Can you
Okay, if the velocity is higher towards the upper part, then it
uh,
would move clockwise.
clockwise? Yes. So it will move like this direction, this direction, this direction. It will move like this direction, right? It will start and moving like this direction. So the fluid, then what will happen? The fluid is going straight, but since you put some object, it started rotating. Fluid rotates. The circular this thing rotate means the fluid also start rotating. Just 1 minute. Somebody wants to try. Somebody wants to join. Okay. So I am talking about card representation of card. So the this circular thing started rotating means the fluid started rotating, right? So the fluid start rotating in clockwise direction. So it represent a card. So card means it is a vector. Vector. So it gives the position and um, it has a magnitude. So magnitude is that cross product. But how do you represent the direction or the position is your clockwise or counterclockwise? Suppose you have something where velocity is high, velocity is low in upper part and velocity is high in the lower part, then it will start rotating uh, counterclockwise. How will the direction you will take? Usually we take clockwise direction means negative. Usually the physicists take. So the fluid starts rotating around that circle in which direction? Clockwise. So it gives the position as well as it is a vector. So curl of v, in that case, suppose v is the velocity v. So curl of v is negative. Because why negative? Because I told you that they took clockwise direction as negative and counterclockwise as positive. So curl of v is negative as it is clockwise. Okay. So what is the definition of curl now? It is just I told about physical interpretation. Now what is definition? Definition is saying suppose F is a vector field. Vector field means a fluid, as I told you first. So F has three components, suppose F1, F2, F3, and they are C1. C1 means first order derivative or continuous. C1 vector field on some region omega. Then what is curl? Curl of F is equal to this cross product. This is nothing but sorry. Oh, what is this? Anyone? This is this IJK. Correct? So this is the magnitude of this curl. So what do you mean by curl is zero? Anyone? What is when the here curl is negative? Suppose in other case it started rotating in the counterclockwise direction, then it is positive. So my question is when curl is zero. When curl of f suppose it equal to zero means what? From your physical point of view?
It means like the velocity in case of this example, the
Uh,
velocity of fluid at every point would be the same.
yes, that means the fluid is not rotating, is irrotational. That is called irrotational. That means the fluid is not rotating. Curl represent how much it rotate. Curl zero means it is not rotating. That means irrotational. Okay, fine. Any question up to this? Then I will move to question answer solving of previous year assignments. Up to this it is okay or any question? There are some new names today. So if you guys have any question, you can ask or write in the chat box also. Otherwise, I will move to the question solving. Previous year assignment solving. Okay, so I'll move then. So the first question is it visible? Fine. Please confirm. Please tell me it is visible or not.
Yeah, visible.
Okay. So I will solve the first question, that is curl of f you have to find. Just now I told you the definition of curl. Just here. So just you calculate and tell me what is the answer, and otherwise I will also do here. So the first question is question number 1. That is where suppose f is something it is given. Let me see what it is given. It is given as x, z, x, y, and 3xz. Okay. So f is x, z, x, y, and 3xz. So tell me what is curl of f. Just you calculate. One determinant you have to calculate, right? I, j, k, del x, del y, del z, x. First component is xz, second is xy, third is 3xz. Okay. So what is this determinant? Just I am taking I. So del y of 3xz minus del z of xy. If you have the answer, you tell me, okay? Minus j into okay. So what is this? I into first is 0, 0 minus j, this 3z minus x plus k y minus 0. Fine. So it is 3 minus of 3z minus x j plus yk. This is the answer, I think. Correct? Let me see. The previous year assignment, it is saying answer is option number x minus 3z. Oh, okay, I have to take minus inside. So it is x minus 3z plus yk. Correct? Answer is option number C. Okay. Any question? Just it is a normal computation of a determinant. I hope you know determinant, right? All of you, please respond by saying
Yes, sir.
answer, or and other people. You can message also if you have any issue in the chat box. Okay, I think yes. Okay, then I will move to the next one. It is a very easy problem because just you have to find a curl. Already f is given. And just now I told you the definition of curl and physical representation of. Can we move? Yeah, I will move. Definitely. We can move to the next question. Okay, okay, we can move. Okay, thank you. So the next question is, you tell me the, okay, the answer already given because it is previous year already, it is answer is given, but you have to prove for any differentiable function f, prove that curl of grad is 0. It is a true statement. Can you prove it? Curl of a grad, curl of grad is always 0. I will write. Question number 2 is for any differentiable function f, from suppose Rn to R. Prove that curl of grad f is 0. That is, curl means this grad f. So it is a 0 means 0 vector because curl is a vector. Okay, so how you will prove? Tell me. Or can you tell me about geometry? That will be very good. I just told about geometry of curl. Yes, Mr. Roy.
So like the gradient will give us a vector which is perpendicular to the vector field,
Ah,
and in that case that vector will also be perpendicular to the curl function or to the grad function which we use to find the curl, and in that way it will be a zero vector.
uh, yeah, but curl means, as I told you, it represent how much the fluid rotate. So, can you tell me in that direction?
So
You
like
are telling right
if
thing.
we
You are
try to
telling.
visualize, for example, we visualize a river in 2D.
Uh,
It is hello.
yeah, tell me.
So we are visualizing the river like the one which you draw, which you drew, and the water is flowing from left to right, and it is rotating the wheel.
Yeah,
Now, if we find the grad of that vector field, then we will find a vector which is like perpendicular to
yes,
the flow
correct,
of water. And
correct.
when we have a force which is perpendicular to the surface of water, it would not rotate the wheel in the direction like
Yes,
clockwise or
correct.
anti-clockwise.
Yeah, correct, correct. Okay, so but I will prove it analytically. Means I will take f is f1, f2, f3, something like that. Or I will take this Rn as R3. Suppose n equal to 3, I will prove for 3. So what is, first of all, what is, suppose grad of f, it is del f, del x, it is a vector. So I'm writing as component wise. Okay, this is grad f, right? So that means it is equal to I del f del x plus j del f del y plus k del f del z. Now, just as you know, curl of f is determinant of I, j, k, del x, del y, del z, and f1, f2, f3. Now, what is f here? Capital F means grad f, right? So, I'll write grad f. So, grad f means del f del x, del f del y, and del f del z. So, now you just compute this thing very easy. It's just determinant. So, it is I into, what is this, del x of del, I am writing directly, okay, del 2f del y del z minus del 2f del z del y. Fine.
Yes.
Del 2f del z del x plus k into del y del x, something. But here it is given f is a differentiable function. So you know the Cauchy's theorem, it is saying that I also prove, not prove, I also state that thing that you can interchange this thing, it is possible, right?
Yeah, the function is continuously differentiable everywhere.
Ah,
But
that is given in the question, I think. It is given in the question. If it is any differentiable function means you can assume that thing. Otherwise, you cannot write this curl. Okay, so with this assumption, the or every term in this bracket is 0, right? It will cancel, right? So it is I into 0 plus minus j into 0 plus k into 0. So it is a 0 vector. So curl of grad is 0. So it is a true statement. Correct? So it is a true statement. It is very easy. There are actually many uh, this type of identity. So I will tell some identity for you. Okay, fine. Some different thing I will tell so that you can also know some more thing. So let me write some identities. So I'm writing in red color. You can prove it in your own. Suppose F capital F is F1, F2, F3, and another G is G1, G2, G3. So number one identity is, as you told, curl of grad is 0. That is different. Here F, capital F and capital G both are vector. So number one is divergence of curl is always a 0. You can prove this thing, okay? And divergence of suppose F plus G, it is equal to what? Anyone? What about curl of F plus G? No, no. Can you tell me? Is it curl of F plus G is curl F plus curl G?
No.
No, yes, it is. It is. It's a properties of determinant, na? A plus G means what? Only in the third column it will change. F1 plus G1, F2 plus G2, F3 plus G3. So determinant has one property that suppose two row are same, but the third row is sum of two terms, then you can write it as two row are same. Third row is suppose A plus A1 plus B1, A2 plus B2, A3 plus B3 something. Then you can write it as both same A1, A2, A3 plus these two are same B1, B2, B3. This is a property of determinant. So curl means nothing but a determinant. So curl of F plus G is equal to curl F plus curl G. That is a true statement. Okay. So these are identity, these you will prove. So how you will prove? Prove is like that. As I told you, determinant things. Divergence you can prove directly. Okay. So curl of, please close this door. My online class. Close. Okay. Curl of F is grad divergence F minus Laplacian F. Okay. This you can prove, I hope. And there are many. You can find it in any textbook. So I'm not writing. I'll write this is last. And there I will write one interesting one that I will tell you. So okay. So one I'm just writing, just tell me. Uh grad divergence F minus Laplace Cn F equal to curl F. Can you prove this last one using any one of the above? Using using 4. Can you prove 6 using 4? Oh, 4 and 6 are same actually. That's what I want to say. So these are standard identities. I'm not writing. There are many. There are actually 12 to 15 identities. Okay, you can try to prove it. Okay, Mr. Obitata Roy, you will try, or all others also. You can try. I will move to the next question. Fine.
Yes,
Uh,
sir.
Pu- Kirutitha. You have any? We can move to the next question. Okay, so next one is again you have to find Carl. So same thing, you have to do the same job. So tell me what is Carl. Just you write this question in your copy and calculate and tell me. I will also calculate. Otherwise. Okay, so I'll write the question number 3. Question number 3 is if f is given as some y z square I plus xyz plus zyzk. Find Carl of f. So this is nothing but the determinant I, Z, K, del x, del y, del z, yz square, x, y, z. So tell me what is the answer. I just wrote the determinant. So tell me what is the determinant. Quickly. I'm waiting for your answer. Okay, so I'll calculate. Anyone calculating or should I calculate?
So I'm calculating.
Okay, okay. Okay, calculate. I am waiting for your answer. Or any other person? Other guys? Raise a hand. Oh, you are also calculating. Okay, fine. Somebody raise a hand. How to check that? Okay, fine. I will show you the question better. This is the question. Yz square plus xy plus yz.
So the answer is zi cap plus 2yz j cap plus y minus z square k cap.
Yes, correct. So this is the answer. Already it is given accepted answer. It is a previous year assignment question. Okay, you are correct. So other person who raised hand, you got the same answer, or you are still calculating? Oh, yes, still calculating. Okay, I will calculate otherwise. You can send write in message, yes or no or whatever. Yes, tell me. You are raising hand. Who is that? It's not coming here, certainly. Okay, I will calculate. Fine. So it is nothing, just a simple determinant. So it is del just if you know the determinant, I know. So it is z. I'm directly writing 0 plus j into, it will give you 0 minus, yes, yes, Roy. Any question?
No, sir.
So you turned your mic off. Okay, so it is k into this thing, huh? K into this. So it is z I cap plus 2yz j cap.
Sir, screen is not visible, sir.
Okay, now
It is visible actually.
Okay, screen is not visible for whom? Who is speaking?
Kirutika.
So from the beginning or now, suddenly?
Suddenly, sir.
Oh, I don't know. Now it is visible.
No, sir.
Oh, for the other people, is it visible?
For me, it's visible.
And Navneet and other Vinotini, Jaya Malini, please confirm. What is visible then? Visible, they are saying visible. You can do one thing, you just log out and again log in.
Okay, sir.
That will be good. Because I think it is visible for others. I don't know. Maybe connection problem for your end. Okay. Oh, okay. She left and let's see. Okay, so this is the answer by the way. So let me wait until she join. Otherwise, she can miss this problem. Okay, so I will show you the next question. It is question number 4. Okay, visible?
Visible, sir.
Okay, visible. So where is that guy? Huh. Now it is visible for you. The question number 4. Hello? Can you hear me? Can you hear me? Q theta. V. V Q theta, can you hear me? Let's see. Is the screen visible? Question number 4, can you see? Otherwise, I will move to this question.
Yeah, sir. Visible.
Okay, great. Okay, so just this is a problem of finding circulation of F around the curve. So what do you mean by circulation of F? I told you last class, circulation of F means integral F dot dr. Now first, the question I will that is given is that C is a boundary of a triangle cut from this plane by the first octant counterclockwise when viewed from above. And F is this, then circulation of F around the curve. So I will first draw the graph. First, first I will write that what is circulation of F. So circulation of F is circulation of a vector F around the curve C is equal to surface integral, sorry, this line integral over this curve F dot dr, that you know. Now, what is this question is saying is that so what is C? C is the boundary of the triangle cut by this plane, by the first octant. So, what is this plane equation? Is x plus y plus z equal to 1. So, do you know what is this? How the graph look like? Any idea?
So it will have three vertices at like 1, 0, 0, 0, 1, 0, and 0, 0, 1.
Yes. So, it is looking like this. Correct. So, what is C? C is saying, let me show you again. C is the boundary of the triangle cut from the plane by the first octant. So boundary of this triangle, whatever I draw. So boundary of this triangle means this. This is C. So how it is moving? It is how the C is going counterclockwise or clockwise. It is given that counterclockwise. So I draw right. Counter means counterclock means reverse. Reverse the clockwise direction. So suppose ABC is the curve This is XYZ, this is O, and this is suppose this is the C. C is the that path. So tell me, C is closed or not? By the first octane means I am drawing in the first octane and viewed
Okay,
from
sir.
the above. Viewed from the above. So C is a closed curve, right?
Yes.
C is a closed curve. So you are in good shape that you can apply which theorem?
Green's theorem.
No. Green's theorem is for plane. You have to apply Stokes theorem. You know Stokes theorem or should I tell?
Yeah, I know it.
Huh?
I know it.
Okay, so what is the difference between Green's theorem and Stokes theorem? Tell me. Is there any connection? I think Mr. Roy you told. So
Yeah, like
please tell.
both of them connect line integral with surface integral.
No, no. Yeah, I am asking about. You are saying Green's theorem. I am saying Stokes theorem. Green's theorem is
Use
saying.
the three integrals, sir.
Tell me.
Use the three integrals.
Three integrals. No, no. Green's theorem means line integral to surface integral. Line integral to surface integral. Stokes theorem also same. Line integral to surface integral. Green's
Surface
theorem.
integral.
Line integral to surface integral. You have to change. You are changing. Na? You are writing some line integral. Integral f dot dr equal to surface integral curl f dot n hat ds. So you are writing some line integral to surface integral. So Green's theorem also is saying m dx plus n dy something. It is equal to some surface integral del n del x minus del m del y. So both are line integral to surface integral. But what is the difference? What is the difference, Mr. Roy? What is the difference? Can you figure it out? Okay, so I will tell otherwise. The difference is Green's theorem is in a plane. In plane. Plane means either it is xy plane or yz plane or xz plane. But Stokes theorem means it is any surface. Stokes theorem, any surface. Any surfaces. Okay, so if you are applying, if you take the projection of this thing in the xy plane, you will get Green's theorem. Projection of whatever this curl.
Okay, like the Green's theorem has only two parameters.
The parameter you can
Like
parameter
either
is
x, y, or yz or xz.
ah
So if it's in 3D, then it doesn't apply.
that's why Green's theorem in plane. That means you have to take a projection of this 3D in the 2D plane. Stokes Green's theorem means what? Green's theorem in a plane, that is either in xy plane or yz plane or xz plane. But Stokes theorem means it is any surface in the 3 dimensions. So how it relate? I will tell you how it relate is that you know na Carl. I am writing Carl F in the Stokes theorem. That is Carl F is some determinant I, J, K, del del x, del del y, del del z, f1, f2, f3. So you are writing it as I into del f3 del y minus del f2 del z plus j into something plus k into something, right? So Green's theorem is nothing but Stokes theorem is what? In the right hand side, curl f dot n hat. Now suppose your n hat is I hat. Suppose. So what will happen? It is del f3. The car. Sorry. suppose your n hat is I hat, so curl F dot I hat ds, the surface integral. It is, what is curl F? Curl F is what? Curl F dot I hat is the first component only, right? Because I dot I is 1, but I dot j is 0. And what is ds? ds is nothing but dy dz here. Because I am taking outer normal is I hat. So I hat means x-axis. So it is yz plane. Outer normal of the surfaces, right?
Yes.
So it is nothing but your right hand side of your Green's theorem. If you can replace f3 by m and f2 by n, something m and n whatever. So it is line integral f dot dr. F means what? f1, f2, f3. So f1 dx plus f2 dy plus f3 dz. Like that you have to do. Okay. So it is f2 suppose dy plus f3 dz. This will be there. So your right hand side is easy. So Green's theorem is nothing but the projection of the Stokes theorem in some plane. So Green's theorem and Stokes theorem, they are both related. Okay, you should not say these are different. Okay. Okay, so but I am not removing all this thing. It will be there. So I will move to the next that question, whatever. This one. So I can apply Stokes theorem. Now you tell me what is curl. Oh, let me write F vector. So I am moving to the question again. So moving to the question. Okay, so F is given by yi plus xzj plus x square k. So you tell me what is F. What is, sorry, curl of F. Why I am writing curl F? Why I am not directly solving this thing? Because this thing, if you want to solve now, you have to solve for this line plus this line plus this line. It is a 3, then you have to take summation. But directly if you solve over the surfaces, this is the surfaces. This is this surfaces viewed from the above. This is S. So directly I am solving over the surface, not through this curve C. So that's why I'm writing it in the Stokes theorem form. So tell me what is this curl? Okay. So what is this curl? Correct? Tell me. Yes.
Yes, sir.
Okay. All others? Okay. So curl you find. Now you have to find n hat out of the normal of F. So how you find n hat? Suppose F is given. F x y z is the curve. It is x plus y plus z. So what is n hat? Tell me. N hat is what? F is any curve. What is the n outer the normal of that curve? It is grad f by mod grad f. Now I told you.
Yes.
So grad f means I del del x plus j del del y plus k del del z of f. So I'm writing directly. It is I plus j plus k. Okay, because every coefficient will come. Coefficient is 1 by root 3. Root over 1 square plus 1 square plus 1 square. Correct? Up to this.
Yes, sir.
So I found curl F and n hat. Now I'll find what is ds. ds is, you know the formula. I also already solved some problem, that it is grad F by mod of grad F. I am taking projection in, suppose in the xz plane. So it is d of a. So dA means dx dz, because I am taking projection in the xz plane, because my curl is a function of x and z. So what is grad f? It is, okay, somebody wants to join.
There was this notation that ds vector equals to like dxi vector plus dyj vector plus dzk vector.
No, but you cannot solve it. This is not ds, this is dr. They are, that are different. R is infinitesimal length. S is infinitesimal surface. You cannot write surface as this. I think that is dr. Okay. Okay, so what is grad f? I just found it is root 3, and grad f dot j hat is 1, because grad f means I plus j plus k. So I dot j dot j is 1 only, and dx dy dm is dx dz. So what your question is, it is saying you have to find this f dot dr. I am writing this as surface integral curl f dot n hat ds. Now I already find all these thing in the right hand side, so I'll put one by one. So I am getting curl f as uh, curl f as minus xi minus 2xj plus z minus 1k, correct? Dot n hat I got as I plus j plus k by root 3. Okay, and what is ds? ds is, okay, I will write it from the left so that it is, I can write in one line. Okay, so it is, the right hand side is equal to double integral over surface S. I am writing minus xi minus 2xj plus z minus 1k dot n hat is I plus j plus k by root 3 into ds is, I just found, root 3 by 1 dx dz, correct? Up to this, now you have to put the limit carefully. That is the most important thing of the whole course, finding the limit. So root 3 cancel out, and I dot I is 1, so it is minus x, j dot j is 1, and k dot k is 1. So this is into dx dz. Now what is the limit? That is the question. Now you tell me what is the limit for z and x. This is your graph. So what is this line? I'll take another color, blue. Suppose. So what is this line? This line represents x plus z equal to 1, right? This line is x plus y equal to 1, and this line is y plus z equal to 1. But I am drawing in the xz plane. Okay. So z varying from what to where? Tell me. Xz plane I am taking, this plane. I'm taking projection. I cannot draw that because it is a 3D graph. You just visualize and tell me. In the xz plane, I have to go from z equal to 0 to x plus z equal to 1, that line. So where z varies? Z varying from 0 to 1 minus x, right? And x varies from what to where? Hello? Hello?
Yes, sir.
Yeah. So tell me z varying from 0 to 1 minus x. You understand? You have to visualize this thing because the graph is like this. Now you are taking projection in the xz plane, right? So z varying from 0 to 1 minus x and x varies from 0 to 1. Maximum value is 1. It is 1 0 0, na? 1 0 0 point. This point is 0 1 0. This point is 0 0 1. So z varying from 0 to 1 minus x and x varying from 0 to 1. This you just visualize because it is a 3D graph. I cannot draw in 2D plane, but I just tell you. So this is z varying x varying from 0 to 1. So what is this integral value? I am writing dx dz at dz dx. This I can do because there is no issue in changing. So I will get at last integral x equal to 0 to 1. I am first integrating with respect to z. So what is the answer? 3x into 1 minus x plus half into 1 minus x whole square minus 1 minus x. Okay? All of you? I did directly. All of you understand this line to this line?
Yes, sir.
Okay, and others? Please tell me. Other people? Oh, already there are 5, no? How many people joined at first? 7. Okay. Is it fine for you, this integral? Other people? Hello? Okay, I think fine. I just directly integrate with respect to z, keeping x as constant. That is the main rule. So again, now I am integrating with respect to x. So it is just a normal integration. So minus 3 will come outside. Now integral of x minus x square dx plus half 1 minus x whole square dx minus 1 minus x dx. Now tell me the answer directly. Half minus 1 by 3, 1 minus x whole cube by 3, and 1 minus will come, so I'll write x equal to 1 to 0 minus 1 minus x whole square by 2, x will come 1 to 0. Fine. Up to this.
Yes, sir.
So, oh, minus 3 I am writing. Oh, sorry. I have to write this. I am writing some bracket problem. These brackets should not be there. Minus 3 is multiplying with only first term. So minus 3 into half minus 1 by 3 plus 1 by 6 into 1 minus 0 minus what is that answer? Half, right? So tell me the answer. Minus 3 into this is 1 by 6 plus 1 by 6 minus half. So this is 2. So 1 by 6 minus 1, right? Is minus 5 by 6. Is the answer. Then let me show you what is the answer. Minus 5 by 6, first one. Yes, correct. So answer is -5. Basically, answer number A. Previous year assignment. Okay, so I'll move to the next question. By the way, you have any question till now? You have any question till now? Hello? No. Okay, no question. Then I'll move to the next problem. Again, a true false type. So S is a surface and F is a vector field perpendicular to the tangent to the boundary. Then curl of F dot ds is equal to 0 is F dot ds. First of all, they are applying Stokes theorem and they are saying it is equal to 0. Is it true or false? S is a surface and F is a vector perpendicular to the tangent to the boundary. Tell me how you visualize this thing. Question number 5. S be a surface and F be a vector field perpendicular to the tangent to the boundary of S. So tell me what is visualize you. S be a surface and F is a vector perpendicular to the tangent to the boundary of S. Suppose S is a surface. F is a vector field perpendicular to the tangent to the boundary of S. So suppose you have a tangent here, so F is perpendicular to this tangent. That means what? That means what? Can you tell me?
So that means like the curl function when we perform.
Yes. That means F is along
The,
the
gra- the grad function gives us something which is perpendicular to the original field. Now, if this is already perpendicular, then that is in the same direction.
that means F is along the normal of the boundary. F is along the normal of the boundary. F is along the normal. So that's it. So that means curl of F dot n at ds is 0. N hat is outer normal, right? And AC, okay, and suppose AC is a closed surface, then you can write it as a Stokes theorem. I think AC is a closed surface here. S be a surface and perpendicular to the tangent to the boundary S. F dot ds over the surface over the C curve. Del S means C here. I think it should be closed. Then it is true. Okay, S is a closed surface then. So you can write it as integral del S F dot ds vector. This is correct, true. Okay, so this is a true statement that S should be a closed. No, not S is closed. Del S, the boundary is a closed curve. Okay, I think this should be given in the question. Otherwise, you cannot write the surface integral the same as line integral because equal to is two times, na. One is equal to with 0 and one is equal to with this. Kept that there. Okay, so I will move to the next question. Fine, up to this. Question number 6 is you have to find one divergent. Any question from you, all of you, till now? This is a problem of divergence and curl, and so you have to know. I told you already what is divergence, what is curl, physical interpretation also. Now just computation. Computation means how to calculate. So next question is how to calculate a divergence of f. Okay, so black. So f is suppose x square y I plus x y z j plus plus minus x square y square k. So what is divergence of f? Divergence of f is I del del x plus j del del y plus k del del z dot x square y I plus x y z j minus x square y square k. Okay, so what is I dot I? I dot I is 1, I dot j is 0. So I will take del del x of x square y plus del del y of x y z plus del del z of minus x square y square. So what is this answer? Tell me. 2xy plus xz minus 0. 2xy plus xz. This is the answer, right? Correct? Any question till now? Any question? Roy?
No, sir.
Okay. So this is the answer. It is option number D. Okay. So I will move to the next question. Tell me. It is given ulta. Integral of f dr is 0 over any closed path D. Then is it imply curl is 0? It is given true, but I don't think so. Okay. So the option is D here. Yes. Tell me. Integral over. Hello. Oh, just 1 second. Hello. हाँ हाँ बोलो. আচ্ছা আচ্ছা ঠিক আছে. হ্যাঁ হ্যাঁ আমি ল্যাব থেকে গিয়ে তোমার সাথে কথা বলছি. আচ্ছা আচ্ছা ওকে ওকে ঠিক আছে ঠিক আছে ঠিক আছে. থ্যাংক ইউ. হ্যাঁ. হ্যালো হ্যালো.
Hello.
হ্যাঁ. Sorry, I'm by the way, did you get the answer? Is it true or correct? False? It is written true, but can you tell me why it is true? Integral of f dot dr is 0 over any closed path D. So that means you can apply Stokes theorem. So is it curl f0 throughout D? then curl of f is 0 throughout D. Tell me. Question number 7. What do you think? True or false?
True.
True. Not true, it is already it is given in the answer. But if D is closed, suppose. I mean the loop is closed. And F is suppose F is conservative. Then it is true, na? I told you. Then but is it true always? Then it is true. If F is conservative, then it is true. But it does not means that curl F is 0, na? This thing does not imply curl F is 0. Okay, I think the answer is given wrong here. This does not imply curl F is equal to 0. So it is a false statement. Just check this. I think it is a false statement. Because suppose integral of fx dx is 0. Can you write f is equal to 0? Here also the same thing happening. Integral of something is 0. You are writing that something is equal to 0. Is it true always? For real function, real analysis.
No.
No. So for same thing you can visualize here. Because integral means area, right? So area means suppose this is area, this is a symmetric area. So integral of f dx is 0, but f is non-zero here. So you can visualize the same thing that here it is false. It is a false thing, but I don't know, maybe sometimes the answer may be wrong. Okay, so I'll move to the next question. By the way, you have any question up to this? Any other queries?
No, sir.
Okay, and other people? Navneet and Jaya, Malini and Vinod. What about the other two? You can write in chat box also if you have any other type of question. Or by the way, did you understand this divergence curl thing? Kir- Kirutitha? Kirutitha?
Yes, sir.
Did you understand the process?
Yes, sir. I have understand the process, sir.
Okay, thank you.
It's okay, sir.
So I'll move to the next problem. Question number 8. That is okay. So it is saying that use divergence theorem. So do you know first of all what is divergence theorem? First line is use divergence theorem. But what is divergence theorem? Tell me. Navneet. No, that Abhit Roy. Somebody left suddenly. Okay. What is divergence theorem?
So it states that the surface integral of f dot ds is equal to the volume integral of the what's that called?
What the volume integral of what?
Grad dot f.
Huh? No. Grad dot f is divergence. Yes, correct. But when you will apply all time?
It works when the vector field is continuously differentiable everywhere.
That is vector field. What about that curve? What about the surface? Is it always applicable? Suppose if is the vector is differentiable, that is correct. But I am asking, what about the surface? Surface is any surface. Hello, is it fine here?
Yes, sir.
Tell me, the surface is any surface or anything, any surface. As I told you in the Green's theorem or in Stokes theorem, your curve is a closed curve. Otherwise, you cannot apply. Open curve you cannot apply. Open means it is not close or it is main point are not same. For what will happen for
It works for the solid figure whose
huh,
boundary is the surface.
huh, surface? I am asking about surface is any surface you can apply. Suppose I gave you a function which is differentiable and whatever, but and some surface. Can you apply divergence theorem?
Now it should be a closed volume.
Yeah, you can say closed surface, not closed volume. If the surface is closed, the volume is automatically, volume is a quantity. Surface is closed means the quantity,
Solid enclosed by yes.
yeah, included inside S, whatever. So, divergence theorem is, let me write, Gauss divergence theorem. Divergence theorem is, I'm writing in short, so it is surface integral to volume integral. So volume is what volume? The volume that is surrounded by the surface. So when it will apply? When you have closed surface. Surface should be closed. So what is the formula? Volume to surface, that is, it is saying surface integral of S over f dot n hat ds. It is equal to the volume integral of divergence of f on dv. Volume integral means dv, dx, dy, dz, triple integral. So you are writing double integral to triple integral. So where v is the volume that is surrounded by the surface S, where S is a closed surface. You should always remember this thing, okay? So, so here question, now I will tell you, or I will tell you the question. Question is, use divergence theorem to find the volume of an integral this, where f is this vector. You can see easily that f is differentiable and S is the surface of a cube bounded by the plane x equal to 1, y equal to 1, z equal to 1 in the first octet. So that means S is a bounded surface. Okay. So let me draw S. A cube. How you draw a cube? Tell me. Tell me how you draw a cube.
The two squares first.
First you have to draw two square, right? One. Suppose this is a square, you just assume because my drawing is not that good. Okay. Good. Just assume it is a cube, okay? It is looking like not like a cube, but it's a cube. So it is giving x equal to 1 means this plane, y equal to 1, z equal to 1. So it is 1, 0, 0, now 0. This is 1, 1, 0. What about this point? Anyone? What is the coordinate of this point?
1, 1, 1.
Yes. This one?
0, 1, 0.
Tell me this one.
0, 1, 1.
This one.
0, 0, 1.
What is left? This one.
So 1, 0, 1.
Right. And this is 0, 0, 0. Okay. So this is a closed surface. So you have to find surface integral f dot n hat ds, where f is equal to some no, let me see what is f. X square minus yz, y square minus zx, z square minus xy. Okay. X square minus yz plus y square minus zx plus z square minus xy. Okay. So tell me, using divergence theorem, what do I write?
Total integral of
Divergence of f
into
dv.
dv.
So what is divergence of f? Sorry, divergence of f. dv means dz dy dx. Where z varying from x, y, what? So what is divergence of f? क्लास चल रहा है ऑनलाइन थोड़ा so what is divergence of f? Tell
So
me.
2x plus 2y plus 2z.
2x plus 2y plus 2z. Yes, correct. Did you understand, all of you? Did you understand how I find this?
Yes, sir.
Okay, so I'm not telling this thing. This is just a derivative and take the dot product. So divergence of f is 2x plus 2y plus 2z dz dy dx. Okay, so tell me the limit of this thing z, x, and y. That is the most important. What is the limit of x, y, and z from this figure?
So
Z
all
varying
0 to 1.
0 to 1, z varying from 0 to 1, y varying from
0 to 1.
x also varying from 0 to 1. Because this is a closed cube. So x varying from 0 to 1, y varying from 0 to 1, z varying from 0 to 1. That's it. Correct. So just to find this integral, then it is very easy. Just I take 2 common outside and just you tell me what is x equal to 0 to 1. First I am integrating with respect to z. So x, it is 1 plus 2y1 plus 2 into half z square 0 to 1 dy dx. So it is 2, x is from 0 to 1.
So you have written 2 outside and inside both.
Oh, you are correct. Then what should I do now? I will Okay, I will remove these two. Correct. Thank you. So, yeah. So it is x plus y plus half dy dx. Now integrate with respect to y. So it is 2 into integral x equal to 0 to 1 x into 1 plus half into y square. So y square is from 0 to 1 plus half into 1 into dx. Understanding all of you? Did you understand this process? 2 into
Understand.
okay. So x integral is half of x square. So x square is 0 to 1, so it is half plus half plus half. So it is 3 by 2. So answer is 3. Okay. Answer is 3. Okay. So this is the answer. 3. Directly use divergence theorem. Okay. So the next F is this. S is a surface solid cylinder between z equal to 0 and a paraboloid. Then using divergence theorem, again here, use divergence theorem to calculate this. So what is divergence theorem? Sorry, what is the surface? It is a plane and a paraboloid between the solid cylinder. So I will draw question number 9. That is okay. So let me x square plus z equal to x square plus y square. This is one. See, this is what paraboloid. And there is another plane is, let me see the question again. Solid cylinder x square plus y square less than or equal to 4 between z equal to 0 and the paraboloid. Okay. So cylinder is x square plus y square less than or equal to 4 between paraboloid and z equal to 0. This is a plane. So you just tell me that graph. Okay. So paraboloid means it is looking like this, right? Sorry. It is z equal to x square plus y square. So it is this type of thing, right? Maybe symmetric, but my drawing is well. Let me draw carefully. Okay, so it is maybe this is a paraboloid because z equal to x square plus y square. That means x square plus y square is equal to 5 means it is a circle here. X square plus y square is equal to 4 means it is a circle here. As z increases, x square plus y square increases. That means the radius will increase, right? So this is a paraboloid. Z equal to 0 plane means this plane. And x square plus y square less than equal to 4 means this cylinder. So less than equal to 4 means here less than equal to, suppose this is x square plus y square equal to 4. So less than equal to 4 means here all the solid cylinder. It is like this, okay? Fine. So you have to find the surface. What is f, by the way? So here f is yi plus xyj minus zk. So you have to find surface integral of f using divergence theorem. That is divergence of f dv over volume. So what is divergence of f in that problem? I del del x plus z. I del del x means it is 0. J del del y means it will give you x, and k del del z means it is giving you 1. So x minus 1. Minus is from this minus. So it is x minus 1 into dv means dz dy dx. Now what you will do, tell me how you give the limit. Tell me what is your plan, limit of these integrals. How you will give the limit? Any idea? It is a cylinder, so any idea of there is something called cylindrical polar coordinate. It is a cylinder, na? But you have to bound it by this plane, so I am not drawing the other portions. Do you know cylindrical polar coordinate?
Yes, sir.
So you have to use cylindrical polar coordinate here, because you cannot write z as a function of x, y, etc. It will be problematic. So cylindrical polar coordinate means x equal to r cos theta, y equal to r sin theta, and z equal to z. So tell me what is dx dy dx in cylindrical polar coordinate? X equal to r cos theta, dz is dz, dy dx is what? Tell me.
dz is 1.
Huh? dz is dz, dz is dz,
Okay,
not
yeah.
1. 1, no, never. 1, if z is a constant, then dz is 0. 1 is not like that, whatever you are thinking. What is dy dx? It is r dr d theta, na? You forgot? Jacobian into dr d theta. So z varying from where to where? Z varying from 0 to
2,
uh,
no, 4.
not 4. Z is what? Z is x square plus y square. This is less than equal to 4. So z means r square, na? Z varying from 0 to r square, r varying from 0 to 2, and theta varying from 0 to 2 pi. Understand?
Yeah.
Limit is most important here in the problem. Okay, somebody maybe ask something. Some sound came, I don't know from where. Anyone have question? Any question? Okay. So z is x square plus y square. So z is r square. Z varying from 0 to r square, but r varying from 0 to 2 and theta varying from 0 to 2 pi. Why r varying from 0 to 2? Why? Because my x square plus y square is less than equal to 4. So r square is less than equal to 4. So r is less than equal to 2. Okay. So theta is 0 to 2 pi, r is 0 to 2, and I will write r cos theta minus 1. Oh, dz z it is come outside. So r cos theta minus 1 into r square into r dr d theta. Understand this line? This line? Directly I wrote. Okay. So it is theta equal to 0 to 2 pi, r equal to 0 to 2, r power 4 cos theta minus r cube dr d theta. Okay. So what is this? R power 4 minus r cube. Now you integrate with respect to r first, then with respect to theta. So it is r power 5 by 5. So cos theta will come outside. R power 5 by 5 minus r power 4 by 4. R varying from 0 to 2 d theta. So I will put first 2 only. So theta is equal to 0 to 2 pi cos theta into 2 power 5 by 5 minus 2 power 4 by 4 whole thing d theta. So 2 power 5 by 5 is 32 by 5. Integral of cos theta is sin theta. Theta varying from 0 to 2 pi. Minus 2 power 4 is 16. Integral of theta is 2 pi. Okay, so it is 0. First coordinate is 0 minus 0. It is 0 minus 4 into 2 pi. So it is 8 pi, right? Minus 8 pi. Correct? Correct?
Yes, sir.
Yes, sir.
Yeah, so yeah, minus 8 pi is the answer. It is also the answer of previous year assignment. Okay, so the next and the last problem. It is question number 10 of previous year assignment. That is saying that if S is the surface. Oh, by the way, any question until this? This answer is option number D. Any question till now?
No, sir. Nothing.
Okay. So S is the surface that is bounded on left by a hemisphere and the middle by a cylinder and on the right by a plane. Oh, so what is integral of f dot ds? You have to apply divergence theorem or not, that you first tell me. Do you like to apply divergence theorem? Let me first draw, or you tell me how to draw. Then it will be good. So this is the last question. So S is a surface. It is x square plus y square plus z square equal to 4 and y less than 0 together. That means half hemisphere. That's why they are calling hemi. Half. In the middle, it is in the middle or what? Let me see again. It is the hemisphere is left by the hemisphere, middle by the cylinder, and on the right by the plane. It's a very difficult graph. Middle by cylinder. What is the cylinder? Oh, it is in the left. So cylinder is x square plus z square is 4 and y in varying from 0 to 2. And on the right, it is by some plane y equal to 2. So tell me how to draw. The surface is like this type of thing. Left, it is a hemisphere. Middle, cylinder. Right, plane. Let me try to draw. So left, it is a cylinder, it is a hemisphere, no? Okay, first I will draw the sphere. Suppose it is a sphere, suppose. And it is a middle by a cylinder. So that means cylinder is x square plus y square, z square equal to 4. That means it is in the xz plane. Here. You have to visualize this thing. And one cylinder. Cylinder means it is not ending, huh? Going on. Oh, now y varying from 0 to 2. So it has ends. 0 to 2, sorry. And z varying from, sorry, and on the right y equal to 2 plane. Y equal to 2 means parallel to xz plane. I don't know how to draw this graph, but the main part is, since hemisphere is given, hemisphere is bounded, and the surface, it is saying that the surface is bounded. Did you understand this? Can I highlight this? Yeah, bounded. So if you are not able to draw the graph also, since it is bounded, you can apply divergence theorem. Suppose, because if you want to directly calculate the surface integral, you have to carefully put the limit of the integration. That is a very important thing. But here limit is finding the graph is actually difficult. So better you transform it to a volume integral. Since the surface is bounded, so directly you can find the volume integral, or directly you can apply divergence theorem. So applying divergence theorem, we get that integral f dot ds is equal to divergence of f dv. So what is f here? F is yi plus zj plus xk. So tell me, what is divergence of f? What is divergence of f?
Is zero.
0. That's it. So that means the integral value is also 0. So that is integral, triple integral of v 0 dv, it is 0. So that then that is integral of f dot ds is equal to 0. This is the answer. Option number A, that is already given. But if you want to find it by surface integral formula, or using that surface integral limit, you have to do many more things. But just using a trick that it is bounded, you can convert it to a volume integral and apply Gauss divergence theorem. So answer is 0 because my divergence is 0. So this is my last problem. Any question till now? Any other question or any question from this assignment? Previous year assignment? You can ask me. Any question you can ask. Avitato, Navneet, and how is the course, by the way? Because today is my last class. How you feel this course? How is the tutorial? You give me your feedback. Avitato Roy, you attend all my classes.
It was very good.
Okay. And how you understand from this tutorial? I think you have saw the videos of Professor Joydeep Datto,
Yes, sir.
but with that, you also attend my classes. I think you and Navneet also attend all my classes. So how you think my class? What is the feedback you want to give? Share some experience. What you learn or what can be more improvise can be done.
Well, yeah, the classes are useful.
Useful. Okay. So and Navneet, you wrote something very good. Navneet, what is your opinion? You attend all my classes, I think. Okay, I did not get you. I think your voice did not come. And other people, you joined class today, and maybe I have one extra class. Actually, I send email to them. I don't know. You guys receive email from them that
There
I
is
have.
no notification from their side.
You receive or not?
No,
No.
no.
Okay. Actually, I gave the date tomorrow, 7 p.m. Let's see by tomorrow. If you get, then you will join in the same link, I think. Same link.
Yes, sir. We have received the message, sir.
Oh, you received
Oh,
one
you
mail.
received one mail.
Yes, sir. We received on mail, sir.
Okay, actually
Okay,
today
actually today is
is my last tutorial class, and tomorrow I think then we have one extra session, just 1 hour. So there I will not solve any problem. I will just tell um, some strategy or some theorem or somehow when to apply those theorem, or when to convert line integral to surface integral, and other things. But I will not solve problems like that. Okay. And you also
Okay,
can
sir.
ask me questions, because I think the extra session is related to your examination that is coming. Extra session is related to your exam, and I hope that this problem solving session will help you to solve this year assignment problems. Did you solve the this year assignment, all of you? Hello.
I haven't solved it yet.
Okay, you solved it. And other people, do you solve assignment?
Yes, sir. I'm coming to solve the assignment. I have some difficulties in that. After seeing this, I can say surely I can solve it.
Okay, okay. Thank you.
Thank you, sir.
Okay, so tomorrow, if you are interested, then you can join. And tomorrow we will discuss some problem, not problem. I will discuss some whatever I did in this 8 week course. I will discuss how you can apply this thing in your exam and in your future also. And
Okay, sir.
that I will upload in YouTube also. That you can get the link from NPTEL. Okay. So any question, Abhitato, now?
No, sir.
Okay. So I can then I will stop my recording. I'll stop my record, or you can leave the chat. Leave the meeting if you have no question, and if you have question, you can.
Thank you so much, sir.
Okay. Thank you. All the best. Jaya Malini, you have any question? Can you hear me? Hello. Jaya Malini, yes. Any question? I think I don't know. I hope you have solved. You can solve this year assignment using this, whatever I solved the problem. It can help you. I hope that. And if you have no question, then you can leave this meeting. Thank you.